All right, welcome. I just want to touch on two goals today, and this is from Monday, September 22nd, if we're talking 2014 right now. But the goals for this lesson, either way, are listed on the bottom here. So I'll star them with a red here. Be able to determine whether a relation is a function, and before we do that, we're going to understand the meanings of domain and range, because that's going to help us in determining a function. All right, so let's focus on those two things. But before we do that, we need to know a couple words. And the first word here is a relation. What is a relation? Well, you actually probably know what a relation is. It has to do with um, something in common between two things or more things. When you think about a relationship, you think of something you have in common with another person or your family or something like that. So right now we're going to talk about a relation in math as a pair. So there's that two things, a pair of numbers in one set. So an ordered pair would be that, or a bunch of ordered pairs. That would also um, work. So if you remember what an ordered pair is, ordered pairs are like this, and then you have your x coordinate and your y coordinate, and that's an ordered pair. You could use an example 1, 2. You go over to the right one, and you go up 2, and that's where your coordinate would be. All right, so just a relation is basically just stating that you have a pair or a set of pairs of numbers. All right, next word, domain. You might think of domain as, a domain name for a website. Maybe think of something with computers. Maybe you remember something with math domains. But domains, just to refresh in math, are really just the possible x values of a relation. So any of the x values that are possible. So you're going to see relations as graphs a lot of times. And so all the x values of the relation. Just looking at those x values. So when you think of domain, think of x values. Not just one x value, just all the x values for whatever the relation is. So in this case, it would be the 1. Since there's only one, it'd be 1. Now the range would be opposite. It's all those y values. So we'll grab this, take that away, and the range is the possible, and I'll fix that. It should say y values of a relation. All right, and I'm going to underline that so you know that I'm talking y values when I think of range. Y values. So all the possible y values. In this case, this relation only has one ordered pair, so the only y value is 2, and that is the range. Okay, again on a graph, a range is going to go up and down. It just depends where it is. Domain is going to go left and right. Depends on where the graph is or what points are plotted. Okay, that's just an intro to domain and range. Now, you're going to see relations in a couple different ways. I'm just going to briefly show you this. A mapping and a graph. Graphs are pretty straightforward. You know that these are points plotted. And again, the relations are, there's four pairs in this relation right here. So there's 4 ordered pairs. If we're looking at a mapping just shows the domain, which again, domain is the x values, and the range is the y values that are possible. And it just lists it. So it lists all the domain and all the range, and it gives you an arrow as to what goes with what. So you can tell here that 1 goes with 4. So 1 is the x value, 4 is the y value, and you got yourself an ordered pair. And that's actually graphed on the graph here. Same thing with the second one. You'll have 2 goes with 0, so 2, 0. Third one would be 3 goes with negative 2, so 3 and negative 2. And the order does matter because the x values are the domain and the y values are the range. The last one would be then 4 and 0. Okay, so that's using a mapping which shows the domain and range to find the ordered pairs to show what goes with each other. All right, then let's introduce the last word, which is a function. A function here is a special type of relation. Okay, so it is a relation. It has ordered pairs where each domain value or x value has exactly one range value, and that's really important. Exactly one. I'll underline that with red as well. Exactly one range value. You can't have more than one. Otherwise, it's not a function. So remember that. If we're looking at an x value, if it goes with more than one y value, it's not a function. So let's look at a couple of examples here. Looking at the first one, well, you can look at it right away at the first x value. Number one, it has two y values, two range values here. That contradicts what the definition of a function is, so it's not a function. No, it's not. Just from that, you don't even have to look at the other two. That makes it not a function. And it helps you to remember, some people think of, again, this is x's and this is the y's. Domain and range, the x's being guys and the y's being girls. And it's saying that guys are not allowed to have two girlfriends. That's just what you need to know here. Guys are not allowed to have two girlfriends. That's morally wrong. Okay, so if that helps you, you can think of that. Otherwise, just know that the definition said they can only have exactly one y value. So if you look at this one, all of these, that has one y value, which is 4, that has one y value, 0, that has one y value, and that has one y value. So this is the domain over here, and the range to the right in this mapping. Each of the domain values have exactly one range value, so we're good to go. This is a function, yes. And this one over here was not. A couple more examples, or just one more example. This one, it's not it looks like they all have their own. And this is where it gets tricky sometimes. This one looks like they all have their own, because there's only one error going to each thing. But if you notice, there's 2 1s, so really you didn't have to list this twice, but you can, and that's saying that 1 goes with 4 and also 1 goes with 0. And if it helps you to note that a function cannot have the same domain value more than once. So if 1 is listed more than once here, it's not going to be a function. So no, it's not a function, because that 1 is going with 2 different numbers. Okay, that contradicts our definition. Now, if you can understand this with mappings, then right away, then that's just an awesome thing, because sometimes this can be very tricky to remember unless you really look at the definition or remember that other analogy we talked about. The easiest way, since these all are coordinate pairs, and I'll list them over here. So this would be 1 goes with 4, 1 goes with 0, 3 goes with -2, and then 4 goes with 0. All right, so you can plot those points. They're points. You can plot them on a coordinate plane. You can graph those, and then you can use what we call right here as the vertical line test. Okay, so if you draw a vertical line, remember vertical means up and down. Draw a vertical line anywhere, and if you can find one that crosses more than one point, that means that the next value has more than one y values, which is not good, then it is not a function. Okay, if it only crosses one point everywhere, then it is a function. So our two examples here are as if you see, this is called a parabola. If you see this parabola, you decide, I'm going to draw a red vertical line to see, oh, there, there, there. Sorry, they're not perfect, but anywhere you draw a vertical line, it's only going to cross at one point. This one only crosses at one point. I'll use a different color. This one only crosses at one point. This one only crosses at one point. This one only crosses at one point. And it's going to be that way for everything. So that means it is a function. Whereas if you take the red pen and you go anywhere, really almost anywhere on this one over to the right, and draw a vertical line, if you look here, crosses 1, 2 points on the graph. Same thing if you do it over here. 1, 2 points on the graph. And that means that it's not a function by the vertical line test. Okay? So not a function there. Let's try one more. Actually, 2 more. You'll see lots of different graphs of things. And sometimes they'll just be points plotted. So if you see 2 points on top of each other, then it means it's not a function. So I'll give you an example here. If you have point there, 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 and there, now it's not perfect, but you'd be able to tell on an actual graph that these two, you do the vertical line test, it goes through 2 points there. 1, 2. That means that it's not a function. So no, it's not a function. That was just a rough little sketch for you in case you wanted to just plot the regular points instead of seeing all, or seeing it connected like we have these. All right, just minimize that there. So here's our last two examples. So you can try them on your own if you want to pause it now. Yes or no, is it a function or is it not? All right, so this one, I did the vertical line test because it works every time. And right there, I already found one spot where it is not a function because it crosses 2 points in the graph, not a function. Once you find one vertical line that does that, then you can stop. The second one here, I'll draw a vertical line there, there, there. I can't find one that it goes through more than 1 point because this one only goes through 1 point, 1 point. This one only goes through 1 point. This one only goes through 1 point, whereas this one over here went through 2 points. So this means that we're good. If it only goes through 1 point, then it is a function. Yippee! So this one is a function. All right, so that's really important to remember, the vertical line test. It'll work every time. All right. Now, just to finish up, I want to show one example, and it's something that we haven't seen yet. This one is just a set of ordered pairs. It's not written with the domain and range. It's not graphed, but you could do either of those if that would help. Or you can look at this and say, I wonder if there are any duplicates of the x values. Okay, so is this a function or not? I'm not sure. We'll say function or not. And look, there's a 3, 5, 7, 8. So there's no repeating x values. So that's good. And it looks like we're good to go then. So that would be yes, it is a function just by looking at that. There's no repeating x values, which back here, if we look at the rule that we have on the bottom, note a function cannot have the same domain value, the same x value, more than once. In our example down here, it doesn't have it more than once, so then it would be a function. If it makes it easier for you, you could visualize the mapping. This as the domain, this as the range, and just list those values. So the domain values would be all the x values. We have 3, 5, 7, 8. The range values would be all the y values here. So we have 6, 7, 7, 9. And you wouldn't have to list both of the 7s if you didn't want to. It just depends on how you're drawing your arrows. In this case, if I listed them both, I just have to draw the arrows straight across. And we are good to go. There are no repeating domain values, so yes, it is a function. And the very last way that you could check this is by making a rough graph. It doesn't even have to be perfect. So say this is 5, negative 5, positive 5, negative 5. And if you graph it, you can plot the points in blue here. And actually, I'm going to make this more fun. And I'm going to use a magic. No, I'm not going to use magic pen. I will use whatever this is. And we'll plot 3 and 6. So about 3, 6 goes right there. It's a little flower. We'll plot 5 and 7. 5 up 7 right there. We'll do 7 and 7. 7 will be right about here and up there. And then we'll do 8 and 9. 8 will be over here. 9 will be up there. All right, so then you can plot it. You can make it more perfect if you'd like. But this one, all you're going to do is take that vertical line test and find, okay, there it only crosses 1, crosses 1, crosses 1, crosses 1. They all only cross 1, so that's good. That means yes, it is a function. Yes, it is a function. Right, so that is determining whether, that's a little review of determining on whether a relation is a function, and then the meanings of domain and range, which domain is all the x values, and the range is all the y values.